Hi everyone, welcome back. So we are starting a new unit. It's Linear Relations Part 2. Yes, we are coming back to linear relations. We started with linear relations when we were still together in school, and then we moved on to a little bit of algebra, and then we did just recently some solving equations, and now we're coming back to linear relations Part 2. So the goal for today is to be able to graph two straight lines and see where they cross. All right, so we're going to start with a little bit of warm up and just, going back thinking about how do you graph a straight line. So this one is already in y equals mx plus b form. So the slope in this equation would be the number with the x, which is 2, and the y-intercept is going to be 4. Okay, so when graphing this line, you want to start off by plotting the y-intercept first. So on the y-axis, you want to put a dot on number 4. So there's 1, 2, 3, 4. So there's my y-intercept of 4. And then you want to get a second point by using the slope. And slope essentially is rise over run. And in this case, it's 2, or we could also say 2 over 1, which means we're going to go up 2, and then we're going to go over to the right 1. We're always going to the right. The question is, are we going up or down? If it's positive, we're going to go up. If the number is negative, we're going to go down. So from your y-intercept of 4, you want to go up 2 spots and over to the right 1. And this is where you're going to end up. Okay, and you can repeat the pattern in the other direction. So instead of going up 2 over to the right 1, you can also go down 2 over to the left 1, down 2 over 1, and so on. So this pattern continues. And then you want to join your points to create your line. Oops. Just going to move it down a little bit. There we go. Okay, for the second equation, this one is not in the y equals mx plus b form, so I'm going to rearrange this equation, all right, using algebra that we learned in the last unit. So you want to have the y on the left-hand side. We want to move the 2x over to the right and change the sign. Okay, so I've done that. So we have negative 12 and then subtract 2x on the right now. And now we need to get rid of the 3, which was the y. So divide each of your terms by 3. And you end up with y equals negative 4 subtract 2x, okay, over 3. Now the slope is with the x, so our slope is negative 2 over 3, and the y-intercept is going to be negative 4. Okay, start by plotting the y-intercept of negative 4. So on the y-axis, 1, 2, 3, 4, I'm going to go down to negative 4. That's my starting point. And from that y-intercept spot, I'm going to use my slope to get a second point. So the slope is negative 2 over 3, which means we're going to go down 2 and then again over to the right 3. We're always going to the right. So down 2 and then over to the right 3. 1, 2, 3. So we end up in that spot right there. Okay, and then just join them together to add your line. All right, so it says graph the following equations on the grid to the right. So we have done that. Okay, and what we're going to look for today is the point of intersection. All right, that's what today's lesson is about. So going just back to that graph, the point of intersection would be where these two points, where these two lines cross, and it would be at that point right there. And that's what I'm going to talk about now. Okay, so a system of equations is a collection of two or more equations with a same set of unknowns, example x, y. To find the solution, we will find the point of intersection while graphing. So for that last example that we just did, the point of intersection is going to be that point where they cross, and it is negative 3, 2. You can check 1, 2, 3 to the left and then down 2. So negative 3, negative 2 would be the point of intersection. Okay, what does it mean? It's the location where the two lines cross. All right, so the solution to a system of equations satisfies both equations. So that point should lie on both of those lines. All right, and the way you check that is you substitute the x and the y into both of the equations to see if it's true, if the right side equals the left side. Okay, so going back, we did left side, right side check for the last unit. So we're going to use the same method here. And so I'm checking to see if this -3, -2 will satisfy the first equation and then also the second equation. Okay, so left side, you're just writing what's on the left side of the equal sign, which is a y, and then on the right-hand side of the equal sign is 2x plus 4. So start off with the equation, and then replace the y with the y that we have, which is -2. And then on the right-hand side, we have 2 times x, so 2 times -3 plus 4. And let's see if this works out to be -2. So 2 times -3 is -6, plus 4 is in fact -2. Right? So the right side equals the left side. Okay, so that point definitely satisfies this equation. Let's see if it satisfies the other equation. So I've written out my equation again. On the right-hand side, we have -12, so there's nothing to do. And on the left, it's 2 times -3 plus 3 times -2. So let's see what we get for that. 2 times -3 is -6, and then 3 times -2 is also -6. -6 plus -6 is equal to -12. And they are equal to each other, so that point also satisfies this line. If we got different values, it would just show that this point does not lie on this line. If it doesn't lie on this line, then it can't intersect with the other line. Okay, second example. This says solve the following system of equations by graphing and then prove your answer is correct. So we're going to do the same thing again. I'm going to start by graphing each of these lines first, and these are already in y equals mx plus b form, so it's a little bit easier. Start by plotting the y-intercept, which is 1 for the first one. So on the y-axis, put your dot on 1, and then use your slope to get a second point. Our slope is 2 over 1. If there's nothing at the bottom, we know there's a 1. So starting at your y-intercept, you're going to go up 2 and over to the right 1. So up 2, over to the right 1. There's your second dot. And now join them with a straight line. There we go. Okay. And for the second equation, this has a y-intercept of -2. So I'm going to put my dot on -2 on the y-axis. And then there's a slope of -1. So we're going to go down 1, over to the right 1, down 1, over to the right 1. And you can continue the pattern, right? Sometimes when you put your point really close, it's hard to draw a nice straight line. So if you continue the pattern, you can put your dot a little further away, right? This goes on and on. And what we're looking for is where do these two lines cross? And you can see very clearly that they cross at the point -1, -1. Okay, so we want to see if we did this correctly, right? We want to see if this is in fact the point where these two lines intersect. So we're going to check to see if this point satisfies both of those equations with a right side, left side check. Okay, so I have written my equation into the left side, right side t-chart. And our y, we think, is -1. So I'm going to plug that in. And then for my x, I'm going to check to see if -1 is going to make this true. Okay, so 2 times -1 is -2, plus 1 is -1, and they are equal to each other. So this point definitely lies on the green line. And let's see if it lies on the red line as well. So plug in -1 for your y and plug in -1 for your x. So here we have -x, and our x is -1. So you end up with two negative signs, so be careful. -1 times -1 is +1. Subtract 2 is -1. And it satisfies the other line as well. Okay, there we go. So that is definitely we've definitely proven that our answer is correct. All right, and the third example I want to do is a word problem. So we have Mike who wants to join a ski club for the winter season. He's considering the two options below. So option 1 is the standard rate, which means he's just going to pay $50 every time he goes skiing. All right, there's no registration fee. Every time he goes, he's going to pay $50. Option 2 is frequent extremist, which means you pay $100 registration, so just a one-time fee. But then every time you ski, you pay $40 instead of $50. So it's a little bit cheaper each time you ski, but there is that $100 upfront fee. And so we want to know which option is better, right? Is option 1 better? Is option 2 better? Right? So for example, if he only skis once that season, then it will cost him $50. He went out once, he paid $50. If he chose option 2, going out once, that one ski trip is going to cost him $140. So you can see that option 1 would definitely be a better option if you're going to go once. Let's say he skis 20 times, right? So 20 times, right, times $50. So if he goes out 20 times, then 20 times $50 is going to be $1,000, okay, for the season. If he takes option 2 and skis 20 times, it will cost him 20 times 40, which is $800. Okay, and then plus another $100 would be $900. If he sees 20 times, then option 2 is definitely better. So at which point, right, is option 1 better? At which point is option 2 better? We want to be exact. All right, so it says write an equation to represent the total cost in dollars and the number of days and for each option presented above. Identify whether the equation represents direct or partial variation. All right, so for option 1, it's $50 per day, which would mean C would equal 50 times N. So, right, so we're letting C equal total cost, and we're letting N equal the number of days. This would be direct variation. I should add that because this would be direct variation because at for 0 days, cost would be 0, right? Because there is no upfront cost. So on the y-axis, we're starting at the point 0, 0. For the second option, where it's $100 registration regardless whether he skis or not, right? Plus $40 for each day after that. Okay, so this one would be $100 plus 40 N, and this would be partial variation because we are starting on 100, okay, on the y-axis, and then increasing from there. All right, so for the second question, graph both equations on the same grid. So I went ahead and did that. So this one, for the first one, we're starting at 0, 0, and then for every day we're going up by 50, which means every 2 days we're going up by 100. Right, so 2 days along the bottom here, up 100, and I just continued the pattern for my green line. And then for the second equation, we're starting at 100, and then we're going up 40 for every day. Okay, so I graph that, and you can already see that these lines cross at a certain point. Okay, so identify the point or the coordinate where the graphs intersect, which is the point of intersection. And if you look really closely, you can see that they're going to intersect at 10 days at $500, right? So if you go skiing, or if Mike goes skiing for 10 days, option 1 is going to cost 50 times 10, which is 500, and option 2 is going to cost 40 times 10 days, which is 400, plus 100, which is another $500. Right? So if he skis for 10 days, the cost is going to be equal. It's going to be $500. What is the meaning of this? It's the point at which the same number of days will cost the same at both ski clubs. Okay, and part E, this is called a solution to the linear system, which is also known as the point of intersection. You want to look to the left of the point of intersection to see which plan is going to be cheaper. Okay, which plan is cheaper for the left side of that point. All right, so you want to see where your two lines are. You can see that cost is on the y-axis, so you're looking for the line that's lower. You can see the green line, right, is lower on the left-hand side of that point. So if you ski between 0 and 10 days, it's better to choose the green line, right? It's better to choose option 1. Option 1 is a better choice because at any point less than 10 days, the graph is lower than the other, which means it costs less, right? Same with if you look at the right-hand side. If you look at the other side, you can see that the brown line is going to be cheaper, right? It's going to be lower than the green line. So any days more than 10, it would be better to choose option 2. Okay, so that's for part G. And then H is one of the two payment options clearly better than the other. It just simply depends on how many ski days you are going to have. All right, so that is the word problem. That's the end of the examples that I wanted to do with you today. For homework, I'd like you to do the definitions, which are on page 1 of the lesson booklet. So make sure that you're familiar with that terminology. And then you're looking at the homework book, lesson 1, pages 2 and 3. And that's it. All right, good luck. Let me know if you got any questions.